When a high-speed object shatters against an invisible wall, we immediately recognize that as the strict boundary of a simulation. In our own universe, we encounter these same hard barriers every day: the absolute speed of light, the microscopic blur of quantum uncertainty, and the collapse of black holes. Traditional physics treats these as the arbitrary, built-in rules of a geometric stage called spacetime. We assume the stage is fundamental, and the limits are just part of the scenery. However, these physical boundaries behave identically to the computational bandwidth limits of a complex operating system. Spacetime functions just like a rendered display. The unbreakable laws of physics are the observable symptoms of an invisible rendering engine reaching its processing capacity. Logos field theory reframes the cosmos as an information-theoretic architecture. It suggests that reality is generated algorithmically, rather than existing as a collection of physical objects. In this paradigm, the fields and particles we observe emerge as the semiclassical shadow cast by a deeper, purely mathematical code. Understanding the universe requires us to look past the physical screen and reverse engineer the cosmic compiler generating the images. The foundational source code of this system is the Adelic ring. It is a mathematical structure that integrates two vastly different ways of counting. One half consists of continuous real numbers, which translate into the smooth fields and undulating waves of our macroscopic world. The other half is the discrete p-adic realm. It operates like fractal logic gates, storing infinite algebraic data in branching hierarchies. This Adelic decompression is managed by the Fargues-Fontaine curve, unpacking discrete data into the smooth geometric grid we perceive as space. Physical reality represents the continuous real-time output of this pipeline, translating abstract numbers into the geometry of the cosmos. Translating infinite mathematical data into a finite physical grid requires massive computational power. To maintain stability, the universe must strictly throttle the decompression rate. The speed of light represents the cosmic clock speed, the maximum rate the compiler can unpack p-adic data into physical space per unit of time. Planck's constant acts as a Shannon entropic safety filter. It establishes the minimum resolution of the macroscopic screen, preventing an information overflow from crashing the local spacetime grid. Quantum uncertainty is a blurring compression filter. If data density exceeds a coordinate's channel capacity, the system pixelates. But if algorithmic complexity completely overloads memory allocation, the rendering engine halts locally, collapsing smooth geometry into a black hole, a localized runtime error. The absolute laws of physics are self-preservation mechanisms, throttling the cosmic rendering engine to prevent a total system failure. If the universe is a rendered output, then the underlying source code is theoretically accessible for manipulation. We could bridge the gap between our smooth spacetime and the discrete code using an s-adic quantum gate. This processor would utilize perfectoid spaces, mathematical bridges that allow a quantum system to interact directly with the valuation states of the p-adic numbers. By injecting specific algorithmic perturbations into these p-adic sectors, we could alter the slopes of the vector bundles on the Fargues-Fontaine kernel. This would allow a user to edit the fundamental constants of a localized area, effectively rewriting the mass of an electron or the strength of gravity before the rendering ever occurs. An arithmetic hack would bypass the laws of physics by editing the mathematical definitions of reality at the core, long before they reach the macroscopic screen. The universe defends its integrity through the Adelic product formula, requiring all variables to balance to exactly 1. A disturbance in a discrete p-adic branch triggers an immediate counterbalancing force in the continuous fields. This global error correction forcefully purges the corrupted information to restore equilibrium. This purged data dump of mathematical errors is physically observable. We see it as Hawking radiation, an encrypted stream of log files leaking from the boundary as the universe's kernel heals itself. Our reality operates as a self-correcting arithmetic computer. The laws we live by are not just patterns in matter, but the functional constraints of mathematics serving as the literal fabric of existence.